Hello, everyone. Welcome. Thank you so much for joining us today. We're glad to have you all here. While we let everybody get settled in here, I'm going to go through a quick introduction, some housekeeping items, and then we will get started officially. My name's Kayla. I'm here representing the Acelab team. We also have Elisa here from Acelab, and then we have Cassandra here from Penetron. She'll be the one guiding us through the presentation today. But before I pass it to her, I'm going to go ahead and take us all over to Acelab for just a moment. And just a moment, you should be able to see my screen. Here we are in Acelab. If you're not familiar already, a great way to...
Sorry, Kayla, I don't think they can see your screen.
Elisa,
I see
okay.
yours.
Can you see it? Okay.
Okay, thank you.
Sorry, thank you.
No, you're fine. Thank you for saying that just in case you couldn't. That would be good to know. Okay, anyways, if you're looking to do any kind of general research, a great place to start is this search bar at the top of the screen. You can utilize our new AI search, or in this case, you can toggle over to manufacturers to find a specific manufacturer. So here on Penetron's page, we've got some really great information for you. We've got Cassandra's contact information right here as well, front and center. So definitely check out their page when you have a moment. We've got video, we've got their products here as well for you to explore. You can click into any one of these pages to learn a little bit more about the products. You can also click here, you can save it into your firm library. That way you have it for future reference. So again, I'll drop this link in the chat for you all to check out. A couple of other things to make note of today. This is an AIA-approved presentation, so we already collected your numbers upon registration, so you're most likely all set there. However, if you're concerned we didn't get your AIA number, I'm going to drop a form in the chat. You can fill that out to make sure that you get credit for the session today. Also, we will be doing Q&A at the end. We'll get to as many questions as we can, so feel free to drop all of your questions in that little Q&A button at the bottom of your screen. You can drop them in there throughout the presentation, and like I said, we'll get to as many as we can at the very end. Also, we will be doing things a little bit different today with the poll questions. So you're going to see some poll questions pop up on your screen during the presentation. Those are just questions throughout to kind of keep you engaged. And so feel free to just answer the best you see fit in those two initial poll questions. And then closer towards the end of the presentation, we will have our typical webinar poll, which is an optional poll. If you're not interested in getting any kind of follow-up, all you have to do is just click the X there, it'll go away. However, if you fill out the poll, we will be reaching out to you via an Acelab conversation a couple of days after the webinar. That's a direct line of communication with Cassandra and her team. So you can respond directly to that email or log into your Acelab account to continue to ask further questions. So definitely keep an eye out for that webinar poll when it pops up as well. And last but not least, we will also be doing a post-webinar survey. So we greatly appreciate any feedback you have. So feel free to leave that there at the very end. And with that being said, Cassandra, I will go ahead and pass over to you to get us started.
Thank you, Kayla, and the Acelab team. I really appreciate you all that's attending today has taken time to learn more about concrete sustainability and long-term waterproofing solutions. Just want to make sure, can everybody see my screen?
Yes, I can see.
Okay, thanks, Kayla. So before I start with the presentation, just like to introduce myself. So my name is Cassandra Gouws. I am a civil engineer and the technical manager for Penetron USA. And if you haven't figured out my accent yet, I am originally from South Africa, born and raised there, studied, and then started my civil engineering career in the consulting industry, designing bridges and culverts. Did that for a few years and then decided to specialize in water retaining design. Did that for a few years, and that's when Penetron in South Africa approached me to become their technical manager. Then I was awarded, or after 5 years of working there, I was given the opportunity to move to the Penetron USA team, and I've been with Penetron in the US for about 7 years now. So just a little bit of background. I'm really excited to be able to share my experience with not only the products, but of the crystalline waterproofing technology as a whole. And as Kayla mentioned, the presentation is an AIA registered presentation, meaning that I am going to keep it generic to the crystalline waterproofing technology. But any testing that I'll be sharing with you today will be Penetron related testing, so on Penetron products. And then at the end of the presentation, I've got a few slides that I'll introduce you to the Penetron range of products, and that's what you'll see on the Acelab platform. Now, the course today is all about how we waterproof concrete and how we make it durable. So we'll first take a look at the composition of concrete, the main causes of deterioration, and then we'll go into actually explaining how the crystalline waterproofing technology protects your concrete, how it makes your concrete waterproof, how it makes it durable and makes it last longer. And we'll also touch on how the crystalline waterproofing technology will streamline your project costs as well as accelerate your construction schedules. So at the end of the course, all participants will be able to analyze the makeup of concrete and the main causes of deterioration, describe how the crystalline waterproofing technology works, demonstrate the benefits of the waterproofing technology and of waterproofing itself, and also shows you how it will positively impact your indoor air quality. And then explain how the crystalline waterproofing technology will not only increase the durability of your concrete, but it will also extend the service life of your concrete. Now, the crystalline technology, we've got solutions for new concrete as well as repairs. So we'll dive into the repair part of the technology as well to show you how it can actually extend the lifespan of existing structures so that we don't have to demolish structures as quick as what we would normally do, and that then preserves the embodied carbon that's inside of your structures. Now, let's start at the beginning. Concrete. Now, concrete as an element is made up of sand, cement, gravel, also known as aggregate, water, and most concrete these days has additives in it. Now, the water that's added to the concrete is added for two main reasons. Now, the first and most importantly is the hydration of the cement. Now, when your cement hydrates, it forms the paste that glues all the other elements together, and it then forms the hard substance that we know as concrete. But 60% of the water that we add to the concrete during the batching process is purely added for workability. Now, once you've placed your concrete into the forms and it hydrates and it starts to harden and the concrete starts to cure, that excess water that's no longer needed for workability leaves the concrete, so it escapes. And it floats to the surface of your concrete. Now, as it moves to the surface of your concrete, it forms like, I like to see it as little snail trails. And then the water pools on top of your concrete, and we know that as bleed water. Now, those little snail trails, also known as, or more technically known as capillary tracks, they stay in place when your concrete hardens, and that's what causes your concrete to be porous and permeable. Now, those capillary tracks, as well as microcracks that form when your concrete hardens, forms pathways through your hardened concrete. And it doesn't only like allow water to get into your livable and habitable spaces or outside of your water containment structures, it also allows egress of salts out of your concrete. The most common one is efflorescence. So an ingress and egress of materials in and out of your concrete. If you had to look at concrete under a microscope or even a magnifying glass, as you can see on the screen there, concrete in essence looks like a hard sponge, right? It's got a lot of voids inside. Hopefully you can see my cursor. You've got these air bubbles, and as these bubbles and voids connect, those are the little capillary tracks, and you've obviously got your cracks. And these are your aggregates, and then your cement paste in between. So it's very, very clear that concrete is porous and permeable by nature. Now, I'm going to be using the terms porosity and permeability quite a bit during the presentation, so I just wanted to make sure that everyone is aware of the difference between the two. So porosity is the number of voids inside of your concrete measured as a percentage of concrete volume. So if you look at the bottom left images, you've got a box and you've got your blue balls in there, right? And you've got a lot of air voids. That's the white space. So that would be concrete with a high porosity. Now, the block to the right of that, it's got your blue balls and then it's got smaller green balls in the air voids or in the air spaces, in the white space. So there's less white space in this block. So in other words, your concrete has a lower porosity because it's got smaller spaces. Now this is interlinked with permeability. Now permeability is the rate of flow of liquid through concrete under a pressure gradient measured as the permeability coefficient. So what that really means is if water can flow through your concrete, so all of those air spaces are linked, then the water will leak all the way through. You will have a permeable material. That's the bottom right image. But if it's blocked by your cement paste and your water cannot get through, then you have impermeable concrete. So hopefully that makes a little bit more sense. Now, concrete as a material, due to the fact that it is porous, is susceptible to deterioration. And these are the four main causes of concrete deterioration. It's corrosion of your embedded reinforcing steel, damage due to freeze-thaw cycles, your chemical attack, as well as reactive aggregates, known as alkali silica reaction or alkali aggregate reaction. And I'm going to give a very brief introduction into all of those, because I believe if we understand the problems, the deterioration factors, then we'll understand the solutions out there a little bit easier. So concrete is strong in compression, but it's weak in tension, and that's why we add reinforcing to our concrete. Now, the concrete is porous and permeable by nature, allowing water, chlorides, carbon dioxides, and various other elements into the concrete. And when that happens, the pH of the concrete lowers. Once it gets to about 9.5 and lower, that's when the passive protective layer around the reinforcing starts to get eaten away, and that's when your steel starts to rust. Now, rust is an expansive process, and it can expand up to 8 times its size. Now, that should give you a good idea of that expansive pressure that is going to be inside of your concrete. And that's when your concrete starts to crack and spoil, so pieces fall off of it, right? And if your concrete doesn't get maintained, that then results in structural damage. So the second deterioration factor is due to freeze-thaw cycles. Now, your concrete is porous and permeable by nature. Water enters the concrete through rain, snow that's melted. And when that water that's inside of those cracks and pores is trapped and it freezes, so we get freezing conditions in the winter, that water, when it freezes, turns into ice, obviously, and it expands by up to 10%, causing excessive pressures inside of your concrete, causing your concrete to crack and spoil. You can very clearly see in the top right photo with those stairs, pieces of concrete actually break apart. Very interesting. A 1 millimeter size crack will actually double in size in as little as 8 freeze-thaw cycles, and that can easily happen in a week or two. So the damage happens much faster than one could think. The third deterioration factor is due to alkali aggregate reactions, known as ASR or AAR. Now, when your aggregates in certain areas are reactive to the cement paste, it forms like a microscopic gel layer around the aggregate. Now, that gel layer is not bad, but as soon as water touches that gel layer, the gel expands, causing internal pressures, causing your concrete to crack and spoil. And then we get more water, and then we get to corrosion of your embedded steel. So overall, not good for the concrete. Then the more obvious one is chemical attack. So whether it's chlorides, sulfates in your soils or in the ocean, de-icing salts, chemical spills, let's say on a factory floor, all of that will eat away the cement paste and leave your aggregate exposed and getting closer and closer to your reinforcing, and then we're back at corrosion again. So chemical attack is bad for the concrete as well. So that brings me to my first poll question, Kayla, is what do all of these deterioration factors have in common? Is it A, impermeable concrete, B, water entering permeable concrete, or is it C, pre-stressed concrete? I just love the poll questions, Kayla. It's like you can see everyone answering them. I get
Yeah.
excited.
Yeah, I know, right? There's real people here.
It's great. Okay, I think we can conclude for now, Kayla. Okay, so I see 4% said impermeable concrete, 94% of you said water entering permeable concrete, and 2% said pre-stressed concrete. So I'm very, very happy to see that 94% of you got it right. And it is indeed water entering permeable concrete. So all of those factors happen as a result of water bringing in sulfates, minerals, chlorides, etc., that causes the deterioration. So now we know, all of you understand, that's the issue. So if we know the problem, what is the solution? We need to lower the permeability of our concrete. So we need to stop the water and harmful elements to get into our concrete in the first place. So to increase the durability, we need to decrease the permeability, so lower the permeability. And how do we do that? Now, there's two ways of waterproofing your concrete. You get your traditional surface applied systems like your bituminous technologies. You get your membranes, whether it's liquid membranes or sheet membranes, your epoxy and resin liners, as well as your bentonite systems. There's so many of them out there, but those are probably your four most common ones. And then you get crystalline waterproofing. And I'm going to touch on the pros and cons of both of them quick, and then we're going to concentrate on the crystalline waterproofing. Now, your traditional surface applied waterproofing systems are very labor intensive because they need to be applied onto the concrete, right? Whether it's a membrane or a liquid. So it's very labor intensive. You need specialized labor because these people need to know how to install it properly. Otherwise, it's not going to be effective. And due to the fact that it's being installed, out in the open, it is weather dependent. So if it's very cold, it can't be applied. If it's raining, it can't be applied. And then once it is installed, it is very easily damaged and it requires maintenance. It also has a service life, so it needs to be replaced every few years. So that's your traditional surface applied waterproofing systems. The crystalline waterproofing system is completely different. Your traditional surface applied creates an actual barrier, right? Now, the crystalline waterproofing makes the concrete itself waterproof. So there's no more barrier. The concrete itself is waterproof. And because the concrete is waterproof, there's reduced amounts of labor because you're pouring the concrete, in any case, and now you actually placing the waterproofing or installing the waterproofing at the same time. So there's a reduced amount of labor. It cannot be damaged because it's not a barrier. The concrete itself is the waterproofing barrier. And you don't need to have any maintenance or replacement because it stays active for the service life of the concrete. So overall, it is a cost-effective solution to protect and waterproof your concrete. So looking at the benefits of the crystalline waterproofing treated concrete versus your traditional surface applied systems is that it will reduce your construction schedule because there's no more installing membranes after the fact. You just pour your concrete. So it simplifies your construction process. And that way it also increases the safety level. They don't need to work behind retaining walls, for instance, anymore with the backfill. That's not necessary anymore because they don't need to install the membranes. They just need to pour the concrete, right? That reduces risk as well as waste on your job sites. And overall, the crystalline system is a value engineering solution. So value engineering means you're getting the same benefit, the same performances, but it is more economical. And it's more economical because we taking away the labor component. And overall, it is a sustainable solution because you have reduced amount of maintenance, an extended service life, and concrete with crystalline technology can be recycled. And concrete that has a traditional membrane system on it cannot be recycled. So that is a very big positive point. So now that you know the difference between the two solutions out there, traditional surface applied versus crystalline, let's take a look at what crystalline waterproofing actually is. It is a powdered blend of active ingredients that you incorporate into your concrete either at the batch plant as an admixture, or you can apply it as a treatment onto existing concrete. But either way, once it's incorporated into your concrete, it reacts with water. So water is the catalyst. And once it is exposed to water, so your concrete is cured with water or it rains after the fact, that water activates the crystal growth process. And these crystals self-heal and seal all of your little pores, cracks, and capillaries up to a 0.5 millimeter in size, which is a 51st of an inch. And those crystals is what decreases the permeability of your concrete, right? So it makes it more dense and it stops liquids from moving through. Now, it's very hard to visualize a 0.5 millimeter, but if you take an average business card thickness, that is approximately a 0.5 millimeter, just so that you know. Now, I know I've said quite a bit and it can be confusing. So I've got a 3D animation here that's going to show you what happens inside of concrete. The sound is not working today, so I'll send everybody, I could send everybody a link if they wanted to hear the voiceover, but I'm going to talk over it or talk you through it. So when you take a look at concrete, whenever it's exposed to water, the water seeps into the concrete because your concrete is porous and permeable by nature. When your concrete is treated with crystalline waterproofing technology like the Penetron system, your concrete becomes waterproof, right? As the water runs through these cracks are typically 0.1 to 0.5 millimeters in size. Those are your typical cracks and voids inside of your concrete, and that water that runs through the concrete grows these insoluble crystals that you can see on the screen there. They are white, needle-like crystals. They knit together and they form and they stop the water or any liquids from moving through the concrete. There's a good indication of what the crystals look like. They knit together, and although they stop water or liquids from moving through your concrete, it still allows air or vapor to move through your concrete. There you can see the vapor moving through the crystal. So it stops the water or the liquid, but it still allows air or vapor to move through, allowing your concrete to breathe. Should cracks appear a day, a week, a month, 10, 20, 30 years down the line, all that crack requires is water for it to activate the crystal growth process. And that's what you saw there now. The crack formed, water ran through the crack, and those crystals self-healed that crack again. So hopefully that makes a little bit more sense and you know what's happening inside of the concrete, because it's a different concept. We know how it works, so let's move on to the benefits of the crystalline technology. Now, there's quite a few on the screen there, but they all based on the most important one, which is the decreased permeability. And because we decrease the permeability of our concrete, you will see your concrete have an increased sulfate resistance. the crack self-healing ability, which we've just touched on now. Your concrete will have an increased chemical resistance with a pH range between 3 to 11. Freeze-thaw cycle resistance, corrosion mitigation, which is obviously very important, and you'll have an enhanced indoor air quality. And all of these give you a decreased amount of maintenance, increased concrete lifespan, and it preserves your embodied carbon. So ultimately, it's a sustainable solution. It's also a sustainable alternative to demolition and reconstruction when you use the repair part of it. And then, as mentioned previously, the concrete can be recycled. We cannot go into all of them due to time, but I'm going to touch on the ones that's bolded. The most important is the fact that it reduces the permeability, right? And there's quite a few tests that you can do to prove that a crystalline waterproofing additive resists high hydrostatic pressures. And one is the Army Corps of Engineers test, the CRDC 48. Then it's the ASTM D5084. And then last but not least, the DIN 1048 test, which is the German standard. I chose that one to put on the slide because it is the most visual. The apparatus that they used is on the bottom right. What we did is we took control sample that's not treated, as well as the Penetron admix, which is the crystalline technology treated samples, and we put them in the apparatus. And what it does is it puts a water pressure of 72.5 psi for 72 hours on the samples. And once it reaches the 72 hours of that water pressure, they remove the samples from the apparatus, and they actually split the samples in half, and they measure the water penetration. So the control sample showed that the water penetrated about 2 inches, that's 53 millimeters, into the concrete, compared to the concrete that was treated with a crystalline technology only had water penetration of 3 millimeters, which is an eighth of an inch. So up to 98% reduction in permeability when your concrete's treated with the crystalline technology. This is also a very powerful slide, once again showing the permeability decreasing and how your concrete that is treated with the crystalline technology can resist high hydrostatic pressures. So this is the same concrete cube, 4 different photos taken over 4 weeks. And there's a constant water pressure of 101 psi from the bottom, so for the entire 4 weeks. After the first week, you can see that the water only goes halfway through. So some of that water has been used and crystals have grown, but not all the way yet. And as time goes on, more and more and more crystals form, and then it doesn't allow the water to penetrate into the concrete. So with this slide, I'd like to say that it doesn't happen, you pour your concrete and then tomorrow it's waterproof. That's not how it works. It needs to be exposed to water to activate the crystal growth process. And then once the crystals have grown, even against high hydrostatic pressure, your concrete is waterproof. And it is a permanent solution. This is one of my favorite slides. This slide shows the self-healing capabilities of concrete treated with the crystalline technology. So you've got 2 samples here. The first sample, they both treated with the crystalline technology, but the first sample is the orange line. The sample has a crack with the width of 0.4 millimeters, which is a 64th of an inch. And then the second sample is cracked with 0.5 millimeters, which is a 51st of an inch. Now, what they did, water just freely ran through these cracks and over these samples. And on the y-axis, you see the water, the flow rate in liters per hour. And then just about 2 weeks, you'll see there's no more water flowing through. So it drastically slows down. And that shows you that the self-healing of the crack takes time, but it does totally self-heal that crack. You've seen a 3D animation of the crystals, but what do they look like in real life? The bottom three images is concrete that's treated with the crystalline technology. You can very clearly see these needle-like crystals inside of the voids and inside of the cracks busy forming. And then the top three images is a control sample. So that's just normal concrete. So you can't see any crystal growth that looks like the one with the crystalline technology. This is a very powerful time-lapse video. It's a wall, in this case, that contains Penetron admix, which is a crystalline waterproofing additive. And as water runs through this crack, it activates the crystal growth process. That is what the crystals would look like under a microscope. And the more you see the white residue form inside of the crack, the less water leaks through, because those are the crystals, and they are self-healing the concrete. Now, take note that in this specific video, it took 4 days for this crack to self-heal itself, but the crystal growth is temperature dependent. So the colder it is, the longer it will take. So, very cold winter conditions, you can take 3 to 4 weeks for cracks to self-heal. It's natural. Concrete also hydrates much, much slower in colder weather. So it's all depending on chemistry. But colder weather, it will take longer. But warmer weather, typically you'll see about 7 to 10 days, your crack will be self-healed. And that brings me to my second poll question, Kayla. Thank you. What is the maximum crack width the crystalline technology can self-heal? Is it A, 0.5 millimeters? Is it B, 0.4 millimeters? Or is it C, 1 millimeter? I really thank everybody for participating. It makes it so much easier for me to know that there's people out there listening. Okay, I think the majority of the people have answered, Kayla. I think we can end. Thank you. So over 60% of the people said a half a millimeter, and 0.4 millimeters was 17%, and then 22% said 1 millimeter. So technically 0.4 is also correct, but it's not the maximum. So 0.5 millimeters is the correct answer. And that is a 51st of an inch. Again, average business card thickness. We cannot stop concrete from cracking. We can try and mitigate it. We can control the crack widths, but concrete will always crack. So if your concrete is treated with the crystalline technology, whether we know the concrete's cracking or not, all it requires is water to self-heal. And that allows us to have a reduced amount of maintenance. A reduced amount of maintenance is we don't need to repair all the cracks that take place anymore, only the ones bigger than 0.5 mils, and I'll get into how we repair them in a few slides. And then because we're self-healing these hairline cracks, it's stopping harmful elements from getting in, and we won't have the corrosion issues, and that also reduces the amount of maintenance. Please make a mental note of that first circle where it says concrete with crystalline technology. There's concrete there with like a greeny colored liquid on top of it. Make a mental note. I'm going to explain to you what that is in a few slides. The last technical slide is showing you how the crystalline technology extends the service life of your concrete. So if you've got a control sample versus a crystalline waterproofing treated sample, this is the admixture in particular. These samples are put in a chloride-rich environment, and then they measure how fast chloride particles actually get into the concrete, to the steel, and the steel starts to rust. And that's seen as the end of its service life. So for a control sample, you've got about 38 years before your steel starts to rust, and then your crystalline technology sample is about 94 years before it starts to rust, showing you that you can have a service life increase by up to 55 years, which is incredible. It's more than double the service life that you get out of it. I'm sure some of you thought in the beginning when I mentioned crystalline technology can enhance the indoor air quality, you probably thought to yourself, well, how can it do that? And it does that because it prevents moisture infiltration into your buildings. And because you're preventing the moisture and water from getting into your buildings, you're eliminating conditions for mold and mildew growth. So that improves the air quality. And the crystalline system has zero VOC emissions, compared to your surface applied membrane systems, which is really, well, traditionally got very high or harmful volatile organic compounds, the VOCs. So you're getting rid of the VOCs, you're getting rid of the moisture so that you don't have mold and mildew growth, and then long-term durability, you're maintaining your structural integrity of your structure over time. So, and all the moisture related issues that go with that. So in a nutshell, you'll have a healthier indoor environment. By using the crystalline technology, you're also preserving your embodied carbon. Now, for those of you that are not as familiar with the term embodied carbon is the carbon emissions that is associated with creating or building that structure, right? So all the materials that we used, the carbon dioxide that was released into the structure, that is the embodied carbon. And by extending the service life of your concrete, by making it last longer with the crystalline technology, by minimizing the maintenance and repairs because of the self-healing and the decreased permeability, you eliminate the need for extra materials, repairs. You don't need to put membranes or liners or coatings on it anymore, which have a very high carbon footprint compared to the crystalline solutions. And you can earn lead points by using the crystalline system instead of using traditional surface applied systems. So in a nutshell, you're preserving it because your structures last longer. You don't need to demolish your structures as soon as what you would if you don't treat them. Now that you know how it works, the benefits, how can I apply them? Where can I apply them, right? If you've got new structures, the crystalline technology, you can add it as an admixture. There's dry shake powders, and from the repair side of things, you've got a topical slurry, which is more the treatment. You've got repair mortars and rapid setting repair mortars for active leaks. And I've got about one slide for each of these. So crystalline waterproofing admixture, that's probably the most well-known one in the industry and most used. It is a cementitious product that gets added to the concrete at the batch plant or at the precast facility. So when the concrete arrives on site, you place it as normal. And then once your concrete's hardened, that's when you cure it with water and the water activates the crystal growth, right? And that's when your concrete becomes waterproof, even against high hydrostatic pressures. So the concrete itself becomes the waterproofing barrier, not susceptible to mechanical damage, and it doesn't change the adhesion properties or anything of your concrete. If you've got existing concrete and your existing concrete is leaking, you can repair it using the crystalline waterproofing treatment, or people also know it as the crystalline waterproofing slurry. Now, it's also a cementitious product. You mix it with water and you literally paint or you spray it on. It is a treatment. You can apply it to concrete on the positive or the negative side. And what I mean by that is if you've got, let's say, a basement, right, a concrete basement, your walls are leaking. Traditionally, you'd have to remove the backfill, repair the membrane from the outside, and then put the backfill back again. With the crystalline technology, you don't need to do that. You can leave everything in place and you can now repair it from the inside. The inside is the negative side. And pressure wash your concrete or grind it to make sure that your concrete is exposed and open capillary surface. Then you apply this crystalline waterproofing slurry or treatment to your concrete, as you can see on the photo there. And then once it's dry, you cure it with water. The water activates the crystal growth and also self-heals and seals all cracks, pores, and capillaries up to 0.5 millimeter in size, making your concrete waterproof. So this treatment works exactly the same as the admixture in the previous slide. It's just applied on the surface. Now, even though it's applied on the surface, it's not a coating. It's just a treatment. So if you would want to remove it or paint your structure after the fact, you would have to cure it with water for 14 days. Now, after the 14 days, you can actually remove it, mechanically remove it, because enough active ingredients would have gone into your concrete to grow those crystals for the lifetime of that concrete. So it is a treatment, very important to remember. If you do want to coat it afterwards, after the 14-day curing process, you would have to mechanically remove it. And then you can apply your architectural finish after the fact, because if you left it on and put your paint over it, your paint would most likely delaminate because of the crystal growth that actually happens on the surface. If you've got cracks bigger than 0.5 millimeters, if you've got honeycomb, construction joints that are leaking, tie holes that need to be filled, that will all be done with the crystalline waterproofing repair mortar. So it is a non-shrink repair mortar that contains the crystalline technology in it. And because it contains the crystalline technology, you can do the repairs from the positive or the negative side. So either side or either one of the sides is fine, because during the curing process, crystals grow into your concrete and actually form part of the concrete matrix, and your repairs don't delaminate. So positive or negative side repairs is possible. Then if you've got active leaks, you no longer need to drain your structures. So if you've got a leak, let's say it's a water tank or even a basement structure, you would use the rapid setting mortar. Penetron's one is called Peneplug. To stop the active leak, this is the cool part of the video. So this is a water tank, it's leaking. They're prepping the hole. And then they take the rapid setting mortar. It's like a hydraulic cement, but it contains the crystalline technology in it. They add very, very little water. They mix it into quite a dry pack consistency. And then they literally plug the hole, right? They hold their hand there for about 30 to 60 seconds, and that is the end of that leak. So you no longer need to drain those structures. Very convenient. And then they finish off the repair with the crystalline treatment, which they're just putting on there. And then that is the repair mortar for a final repair. Typical applications, I would say you could use the crystalline technology in any structural concrete that you want waterproof, durable, sustainable, or resilient. So just a few mentions. Any cast in place parking structures, especially in post-tension decks or slabs, that would be a good application. I would not use it in your Lego type structures, like your metal, concrete on metal deck, or concrete on like your little concrete topping on your precast elements. That is a no-go. There's too much movement there. The crystals will break. But your slab on grades, your hydrostatic slabs, any foundations, pile caps, elevator pits, some precast things like manholes or underground vaults, tunnels, subways, wastewater treatment plants, and water treatment facilities. There's so many examples. Aquariums, pools, they would all be very good applications for the crystalline waterproofing technology. I'm going to go through these examples very quickly. This is just a project, Brickell City Center in Miami. They used the crystalline waterproofing system in the elevator pits, hydrostatic slab, pile caps, and retaining walls. Originally, a membrane system was specified, but you can see there's a lot of groundwater and they physically couldn't install it. So they switched to the crystalline system, specifically Penetron, and then they just poured the concrete as normal and they got their protection and waterproofing that they needed. It's also very good in shotcrete applications. So this is Park Avenue Tunnel. They redid this tunnel. They did like a structural lining to it. They needed new reinforcing installed. So 9 to 12-inch shotcrete lining was done. So shotcrete is a very good application for the crystalline waterproofing additive, but not gunite due to the mixing. But shotcrete is a good application. Any precast structures that needs to be waterproof or protected from like sulfates or chlorides, that would be a very good example or application. And then marine structures, so anything that's exposed to these chlorides and sulfates for corrosion resistance. So whether it's pile caps, sea walls, concrete slabs, all very suited. And then lastly, the water treatment plants or wastewater treatment plants. So whether it's the containment structures like the headworks, the grid chambers, primary, secondary clarifiers, settling tanks, aeration basins, all of those would be good applications, not only from a waterproofing point of view, but for durability. So protection against all those chemicals they use to treat the water, as well as the sulfates. So in summary, concrete is porous and is susceptible to deterioration. And the crystalline technology will mitigate the deterioration by decreasing the permeability. And know that there is a complete crystalline system, so not only an admixture, but repair materials as well, so that it can work together not only for new construction, but as well as repairs. And then crystalline treated concrete will have a decreased carbon footprint, increased durability, reduced maintenance, and it preserves the embodied carbon by extending the service life of your concrete. So in a nutshell, I really and truly believe that the greenest building is a preserved one. So that concludes the AIA portion of the presentation. I'm just going to mention the products, a few of them that we have listed on Acelab that completes the Penetron system. The most common one is Penetron Admix SB, which is our crystalline waterproofing additive that gets added to the concrete at the batch plant. Then if you've got any construction joints, we've got a swellable water stop called Penabar SW, and that is installed along all of your non-movement construction joints, as well as around all of your penetrations. And then if you've got any repairs, the Penetron is the slurry, so the treatment that you apply after the fact to existing concrete. And then the Penacrete mortar is your crystalline waterproofing repair mortar that you can use to repair any cracks bigger than 0.5 millimeters, honeycomb, tie holes, all of that. And then the Penaplug plugging active leaks. So that's for the active leaks, that video that I shared. And then I'm going to skip that video because you can't hear the sound, but I'll share it with all of you. It's just to show how it all fits together. But I mentioned that you must remember that green liquid in that little circle. And that is our Penetron Admix, the crystalline waterproofing additives visual quality control that's built in. Now, we're the only admixture in the world that contains a tracing agent. So when they place the concrete, the bleed water that comes to the surface is luminous green, like you can see on the screen there. Now, although it is quite a bright color, do not be alarmed. It will not stain your concrete and it is non-toxic. It is NSF 61 approved. And that means it is safe for the environment and it is safe for use in potable water structures or water applications. So the green also dissipates as the bleed water evaporates, so you don't need to worry about that. It's purely added for quality control reasons for the people on the job site to know that it has been added to the concrete once they've ordered it. And please know that we like to work with all of you as a team. Acelab makes it super easy to connect with me, and I can connect you with our local account managers that can provide you with on-site support. But feel free, we help with complementary support services like drawing markups, specification review, if you want custom submittal request packages, or even mixed design reviews. We can offer you those services, so please make use of that. We love working with you as a team. And then I would love to open up the floor to questions. And for those of you that are not staying, thank you so much for your time. I really appreciate it.
Amazing. Thank you so much, Cassandra. That was amazing. Yeah, let's jump into these questions. So, first one we have is, are there any scenarios where you would not want to use crystalline waterproofing?
Yes, so I mentioned two, but I'll go over it again. So firstly, I would like you to reach out to me so that I can take a look at your drawings and make sure that that the application is ideal for what you're looking for. I would definitely not recommend using the crystalline system in anything that has a lot of dynamic movement, correct, or dynamic stresses, because these crystals are brittle of nature. So if you're going to have a slab on a metal deck with that little concrete topping, if you put Penetron admix in there, and there's a lot of flexure that happens, those crystals that are now waterproofing your concrete will break as it moves. So concrete on metal deck, if you've got precast panels with a little concrete topping, that's also not a good idea to use it in there. And then roof slabs. Roof slabs, we do not recommend using it as a sole or a primary waterproofing solution. The reason for that is roof slabs experience frequent temperature fluctuations, right? So you've got a lot of expansion and contraction that happens, and that causes regular cracking. So although, yes, we will self-heal those cracks that keep on forming, so it stays active for the lifespan of the concrete, and all it needs is water, but I'm telling you, the person living in the condo below is not going to like it being damp or leaking, every time it does crack and waiting a few days for it to self-heal. So in a roof slab, due to thermal expansion, contraction, regular cracking and self-healing cycles, I would not recommend it in that. So those are probably your three main ones that I can think of now.
Okay, that's great. And that same person actually added a clarification here. So maybe you can add on to this
Mm-hmm.
or still answers the question, but it says to clarify my previous question, are there scenarios where it would be better to use traditional sheet membrane where when waterproofing is required rather than the crystalline admixtures?
Yes, so if there's any flexure or movement, definitely do not use us, use your membrane systems. And if you've got any block work, brickwork, things like that, you cannot use the Penetron system on anything except structural concrete. So you would have to use the traditional membrane system. That's why I feel there's space for all of us in the market. Applications differ.
Amazing. All right, great. So next question is, I love the idea of having an integral system as it helps with the application and continuity, especially compared to traditional methods. How does one manage water and hydrostatic pressure with the crystalline waterproofing? With a dimple mat type waterproofing, I believe that helps with channeling water to the foundation drain. How does this system replace that?
That is a very good question. Okay, so firstly, the dimple mats normally get put behind your retaining walls to, like they said, drain the water down so that that hydrostatic pressure is not against your wall, right? And that's due to two reasons. A lot of the time, it's that they don't have to design the wall to withstand those forces. And I'm not saying from a waterproofing point of view, I'm talking from a structural point of view. You would put in a lot more reinforcing if it had to withstand that water, correct? And not just the sand or the soil. That's taking it away. But if you did design your wall to withstand those hydrostatic forces and they do want to take away the dimple, you can put the Penetron admix in there and it can withstand high hydrostatic forces up to 650 feet, I think it is, of water pressure. So water pressure is not a problem for us as long as the wall is designed to structurally be in place to withstand that force. But from a waterproofing point of view, we can withstand that.
Amazing. Perfect. All right, next question. Can this be used in repairing existing concrete? What is the best way to protect the existing concrete surfaces?
Yes, it can be used to repair it, and just to clarify, this would be a waterproof or durability-based repair, not structural repair. That would be up to the engineer to give those recommendations. Um, you would use a combination of Penetron and Penacrete mortar. So Penetron is the crystalline waterproofing treatment, so that's the one that you paint on. And then the Penacrete mortar is the repair mortar that contains the crystalline technology in it. So you would use a combination of those two to do the repair, depending on what it is. Is it a crack repair? Is it a honeycomb repair, tile hole repair? Please feel free to reach out to me and I can send you typical details because it's always hard to explain, right? But I can send you typical details and repair recommendations that take step by step, takes you through the process of doing the repair. And the repair can be done from the positive or the negative side of your structure.
Gotcha. Okay, thank you. All right, and next we have, can the additive or the applied crystalline method coincide with pigmented concrete?
I get this question a lot. I'm assuming they're talking about the admixture. So the Penetron admix can be added to colored concrete. It can even be added to white concrete because it's not going to affect the color because you add so little. The Penetron admix is dosed at 1% by weight of total cementing materials. So you're looking at on average, like a 6.6 pound bag. So it's this little bag per cubic yard of concrete. So it does not affect the color of your concrete.
Amazing. That's great. All right, I think we have time for maybe one or two more questions. Next we have, is Penetron slash crystalline waterproofing used when part of the concrete slab is exposed to the exterior, either on a balcony or slab edge, but most of the slab is contained within the interior of the building?
I say that's one of the questions that I get the most from architects that do condo building. So yes, you can use the Penetron admix in those slabs. I have, although, noticed that they do not want to treat the entire slab because they don't feel the interior slab needs to be treated, right? And then it's just these balconies. So for budget reasons, it normally doesn't get approved because you'd have to pour the entire slab with the admixture in it because it would be a logistical nightmare to say, okay, these two trucks you have to pour here, then these two trucks you have to pour there, with the Penetron admix in it, and then have the non-treated ones on the inside. So that would be, it's not impossible, I've done it, but it is a logistical nightmare to be able to do it. So for the balcony applications, typically they opt to not go the crystalline route because they don't want to treat the entire slab.
Amazing. Thank you. And for the sake of time, we'll stop there. There are a few more questions, but Cassandra will be able to follow up with you all with answers to any unanswered questions. So, Cassandra, would you like to wrap us up with any final notes today?
I just thank you again to Kayla and Alyssa. And I would also like to say if you have any trial applications, because I know sometimes Acelab offers samples, that would be a little bit harder to do. But if you are thinking of using us and it's in a little trial application, please let me know, and I will most likely be able to support you with that.
Yes. Yeah. Thank you for mentioning that. That's perfect. And folks, as I mentioned at the beginning, if you filled out that poll, keep an eye on your inbox over these next couple days. We'll be connecting you with Cassandra and her team via an Acelab conversation. So again, that's a really great way to have some continued conversation, ask additional questions, talk about specific projects or trial applications. So definitely keep an eye out for that. And we thank you all for joining. We thank you for a really great presentation, Cassandra, and we hope you all enjoy the rest of your day.
You too. Thanks, everybody.
Bye.